Hello my dear students, it's a pleasure to meet you in our educational program of Geology and Environmental Science. I'd like to remind you, last time we talked about the constituents of the Earth's planets and the geological structures. In our today's program, we'll talk about minerals and rocks. Let's start with the following. Minerals. This is the first subject in this episode. What is the definition of a mineral? In general, it is a valuable material extracted from the earth. For the point of view of mineralogists, it is naturally inorganic element or compound having an orderly internal atomic structure and a specific chemical composition, crystal form, and physical properties. Also, we have coal and petroleum are derived from the organic origin, but they are considered as minerals due to their high economic value. The majority of minerals have compositions that changes due to replacement of one another. We find that main item in definition of minerals is its crystallinity. It means its orderly arranged internal structure. Also, we have specific properties for minerals like physical properties as color, cleavage, fractures, hardness. Depends on the chemical composition and the type of the minerals, how minerals are formed. The majority of minerals are formed of two or more elements which unite to form a compound or constant composition. We find that limited number of elements, about 8 elements, form more than 98% by way of the rocks of the crust. They are oxygen, it forms 46.6% of the Earth's crust, silica 27.7%, aluminum 8.1%, iron 5%, calcium 3.6%, sodium 2.8%, potassium 2.6%, magnesium 2.1%, and only 1.5% for other elements. These are the most important 8 elements. They form all the Earth's crust by uniting with other compounds. Minerals divided into several groups. Also, we have some specific groups which are very common, like silicates, followed by groups in abundance like carbonate group, and then the economic minerals of oxides and sulfate, and the native minerals of specific metals, individuals and others. How can we divide the mineral crystal into systems? Minerals and crystals can be divided into several systems depending on the length of the crystal axes and the angle between the axes as follows. The cube system or the cubic system. This is very simple type of crystals where the axes, as you see in the front of you, the 3 axes are equal in length and height. Also, they are perpendicular on each other, so they are normal to the other axes. This is the greatest type of crystallinity in the crystal system, where gamma equal beta equal alpha, and this is the angle between the axes, and the axes lengths like A1, A2, A3, they are equal. So the angles are equal to 90 degrees, and the axes lengths, they are equal. Now, my dear students, we go to the rhombohedral system. It is similar to the cubic system, but the three axes are not equal. So we have the smallest one, which is A, and the width, in the width side is B, and the long one is the C axis. Crystal includes three different crystal axes in length, and they are perpendicular to each other. Alpha equal beta equal gamma, C not equal to B not equal to A, and the crystal will be columnar in shape. In vertical direction is more than the other two horizontal directions. Tetragonal system. We have more symmetry here in tetragonal system. The horizontal axes, they are equal. A equal to A2, and the vertical axis is different, is larger than both of these axes. Crystal includes three crystal axes. They are perpendicular to each other, where the C axis is fourfold axis of symmetry. Horizontal axes are equal, and the third different from them in length, which is the C axis. As you see, gamma equal to beta to alpha, C not equal to A1 and A2. We still have perpendicular axes. The angle between these axes is 90 degrees. Let's go to another high symmetry type of crystals, which is the hexagonal system. It's close to the tetragonal one, but in this type of crystal we have three horizontal axes to control the multi-crystal faces. So we have A1, A2, A3, and in this time they see with six-fold symmetry. Crystal includes three crystal axes, horizontal, equal in height, and intersect with each other at equal angles. The fourth axis, this one is perpendicular to the horizontal ones, and different from the length in the length, and we have six-fold symmetry and a crystal horizontal symmetrical plane. This is very important. We have horizontal symmetrical plane because we have similar condition in trigonal system, but trigonal system lacking this six-fold symmetry, and it doesn't have the horizontal symmetrical plane. The plane and the trigonal system, which is the C axis, it is threefold symmetry. Now let's go to our properties here. C is not equal to the horizontal axes A1, A2, and A3. Trigonal system. Crystal include three crystal axes, horizontal, equal in height, and intersect with each other in equal angles, and the fourth one, which is the vertical axis, is perpendicular to these axes. It has threefold symmetrical property, and there is no horizontal symmetrical plane. So we have also C is not equal to A1, A2, A3, and also it is perpendicular to these horizontal axes. Now, my dear students, we're going to monoclinic system. With this system, we start having distortion in the crystal form. We don't have this perpendicular property of the vertical axis. We start having more than 90% angle between the C-axis and the horizontal ones. We start with the monoclinic system. Crystal includes 3 crystal axes, different in length, 2 perpendicular axes, and the third stand. Most of them belong to the metals, this species. We have alpha equal to gamma but not equal to beta. Also we have A is not equal to B is not equal to C. This property is quite similar to the rhombohedral crystal, but the angle is normal in rhombohedral crystal. It's not different as the monoclinic crystals. Now we have the mass distortion here. We have two angles more than 90 degrees. We have the triclinic system. Crystals include 3 crystal axes, different in height and non-perpendicular too. All of them are not equal. They don't have the relation of normal angle. So alpha is not equal to beta, is not equal to gamma, A is not equal to B, is not equal to C. Since all systems have 3 axes except crystalline symmetry. Hexagonal and trigonal systems have 4 crystal axes, as we see before. Write short notes on the optical properties of minerals. This deals with the interaction between light falling on the mineral and that reflects from its surface. This is the color. For luster, it is the intensity of light reflected from the surface of mineral. And we can classify the mineral according to their luster into metallic luster, and most of metallic minerals have this type of luster. Resemble metals in their bright and strong reflection. Non-metallic luster, where we have vitreous, glassy, pearly, silky, and resinous, and diamondly. Dull or earthy, as most of rocks they don't have this kind of light reflection, which have low intensity luster. Color depends on the wavelength of light reflected from the surface. The presence of impurities may lead to misidentification of mineral color. Like the quartz is transparent where it is pure, SiO2. Rose quartz and amethyst, it is purple in color due to the small amount of impurities of titanium in quartz and ferric in amethyst. It's also SiO2 but with purple color, so we call it amethyst. A smoky quartz that have black color due to the break in its bonds when exposed to high radiation. Also we have milky quartz, which due to the presence of gas bubbles. Also we have sphalerite. When pure it is yellow but turns brown due to the iron impurities. True color, unchanged color, such as sulfur, has yellow color. And malachite, which is hydrous copper carbonate, has green color. Play of color, it's another optical property for minerals. This is the change in mineral colors when moved in the front of a source of light. This property characterizes precious and semi-precious stones used as ornamentation and in gemstones. Light falling on diamond reflected and refracted into red and violet color. Precious opal, also known as the cat's eye mineral, where we find the fibrous nature of the mineral. Transparency. The transparency of mineral is the degree to which light can pass. Also, accordingly, we can divide the mineral into transparent minerals, where we can see the other side from the mineral to other objects. Also, we have translucent, which is semi-transparent minerals, is the picture seen through it, not clear. And finally, we have opaque minerals, if the mineral doesn't transmit light at all. We have also streak, which is an optical property. It is the color of the powder of the mineral on the streak plate. The streak has a constant color for the minerals that have different colors and not affected by impurities. So streak is very important to define the real color of the minerals. They have the same streak color, where they can have different colors according to the impurities. What are the stages of rock cycle? We have weathering, where the rock breaks down into small fragments under the disintegrating processes of water, wind, and ice, which are the mechanical and chemical weathering, and how basic the rock breaks to small fragments that are different in shapes and structure. Then we have erosion and transportation, weathering products removed by different agents of transportation. We know that air and water are the most important agents for transporting these products of weathering. The rock detritus, according to the velocity of wind or water currents and the size of these detritus. The load of the river, it means the quantity of transported substances, depends on its ability to carry or load the detritus. And then finally we have deposition. Grains have several steps during their journey, and they have stops depending on the variation in the power of the transporting agents. Detritus is deposited when transporting agents loses energy and cannot carry the grains anymore. When they settle to the bottom, in this respect, grains deposited anywhere on the continent will soon or later be transported once more to continue their trips to the sea, where most of sedimentary rocks have been deposited. Rocks are usually classified according to the environment of deposition into continental, deposited on the continent, and marine, deposited on the sea or ocean floor. And also we have intermediate between the two environments, or the two types of environments, like deltaic environments, in which part of the sediments is deposited on land and the other part deposited in the sea. Petrification and solidification process. This is a very important process in the rock formation. Under the pressure of the deposited sediments, the lower layers gain and tied together, and also cohesive materials tied down between the grains, which lead to the changes of the loose sediments to sedimentary rocks. Also, we have metamorphism processes. The sedimentary rocks or other rock are subjected to great depths to high temperature, increasing and pressure, and changes those rocks to new rocks called metamorphic rocks. Usually include changing their mineral and texture to new constituents suitable to balance the new circumstances of temperature and pressure. Finally, we have the fusion process. At great depths with very high temperature and pressure, metamorphic rocks and other rock are melted when the minerals reach to the melting degree. And also we have cooling and crystallization. This is the process of the forming of the primary rocks or igneous rocks, when molten rocks are exit from magma room and subjected to low degrees of temperature and pressure. Igneous rocks may be underground, such as granite, or rushing to the surface in the form of the lava and the areas of the volcanic eruptions, vastly cooled to form basalt and andesite. Compare between the three types of rock. Now, my dear students, we come to a very important question. How can we compare between the three types of rocks? Igneous, metamorphic, and sedimentary rocks. Igneous rocks, they are primary rocks or mother rocks. For metamorphic rocks and sedimentary rocks, they are secondary rocks. They are formed from other type of rocks. For the primary rocks, which is igneous rocks, it is formed by cooling of magma. However, it is underneath the earth or outside the earth. For metamorphic rocks, it is formed by increasing pressure and temperature on other type of rocks, even metamorphic rocks itself. It is metamorphosed when it gets higher temperature and pressure. For sedimentary rocks, it is formed by the common extracellular conditions, environmental changes, breaking of rocks, transportation of the detritus material, and then the deposition. Also, we can differentiate between the three types of rocks by being crystallized. The primary rocks and the metamorphic rocks, they are crystallized. For the sedimentary rocks, it is mostly non-crystallized rocks. Especially some types of sedimentary rocks, they are deposited with much crystals, so the rock seeing crystallized. Also, one important differentiation between the three types of rocks is the presence of fossils. So for the primary rocks coming from the molten material, we don't expect to see any type of fossil. For sedimentary rocks, it is formed in normal conditions where the organisms lives, so they form fossils within the sedimentary rocks most of the time. For the metamorphic rocks, we couldn't also see any type of fossils unless the metamorphosed rock coming from the sedimentary rocks. So sometimes in metamorphic rock we can see fossil remains or relics of fossils. By this, my dear students, we come to the end of our today's program. Until we meet next time, have my best wishes and goodbye.